What's going on? Why aren't they calling us to get on the flight?
We are so sorry to announce that your flight has been delayed for an hour. We will do our best to get you on your plane as soon as possible and flying smoothly soon.
Oh, come on. If I had known it would be delayed for a whole hour, I could have gotten food. I'm starving and I need any breakfast.
Hey, Emilia, what are you still doing here? I thought you had a flight to catch. You said you couldn't get coffee with me because you needed to go on a flight.
Yeah, well, my flight was delayed. Now my whole schedule is messed up.
Dang, it would have been pretty easy if we knew if our flight was going to be delayed beforehand.
Taking a step back, as we can see from the scenario, an accurate estimation of flight delay is critical for airlines because the results can be applied to increase customer satisfaction and thus the incomes of airline agencies. This ends up affecting our economy. Anyway, back to the skit.
My flight was delayed too. It sure would have been nice if I had known beforehand.
Funny you say that. That's why the Shimmering Pythons have made a product to help customers predict flight delays, leading to more customer satisfaction. Here is our product disclaimer. We are not sponsored by Southwest. This is Delay Relay, the product that keeps you flying on time. Delay Relay is an AI product that can help you predict flight delays. Using machine learning and data from your flight, Delay Relay is able to detect delays that may occur. We are dedicated to keeping you updated and saving your time. Some background on our website include the fact that we took a Bootstrap template and renovated it, and the color scheme is present throughout the website. And you can also see it in our logo and throughout all of the different sections of the website. The goal of this project is to predict whether or not a flight will be delayed based on 500,000 data points with variables such as airline, airport, weather, and square footage of the airport. This problem is a classification problem, as there are only two possible outcomes. A flight will be delayed or a flight will not be delayed. And then Delay Relay is the AI product that is created to keep you flying on time and aware. And after thorough research, we realized that people struggle with staying updated on flight delays. So because of this, we created a product for people to stay informed and fly smoothly.
Before we were able to fit in trained models, our data needed to undergo a few steps first. First, we needed to do a little spring cleaning in the middle of summer. To make sure that our model would work accurately, we removed rows and columns that were unneeded or unfinished. So an example of this would be our data for Aberdeen Airport, which only had 2 recorded flights. That could have easily messed up our data, so we dropped the rows containing that airport. Our team also took into account the airport size and weather at each airport because we believe that these factors are key in determining a flight's delay status. And since this wasn't in the original data set, we decided to add it in manually. Then we took our newly inputted data and original clean data set and put them together using the Python library pandas. The final step before fitting our model was encoding our categorical variables, which were the airport and airline IATA codes, which makes the data readable when you're training the models.
Moving on to machine learning, we've used a total of 3 machine learning models, XGBoost, SVM, and Random Forest, to put our data into. As stated before, since we are trying to determine whether a flight will be delayed or not, this is a classification machine learning problem because there are only 2 possibilities: to be delayed or not to be delayed. So the first model that will be, the first model I'll be introducing is SVM. SVM is a model that tries to find a hyperplane that distinctly classifies the data. Running SVM gave us an accuracy of 66.7%. It ran for a total of 480 minutes. The diagram below is a visual of how SVM works. So the red line would represent the hyperplane, and the dots on the dashed lines right there are support vectors. This is the heat map that was generated after running SVM. The top left corner are true negatives, and the bottom right corner are true positives. Moving on to XGBoost. XGBoost uses gradient boosted decision trees to classify the data. This is a visual of how XGBoost works. It gave us an accuracy of 66.4%, and it ran for 16.2 seconds. So XGBoost was my personal favorite, as it only took like 10 seconds to run. This is a heat map for XGBoost after running the model. Random forest uses classic decision trees to make predictions. As you can see right here, it splits the data into trees and then outputs a final result after a majority vote. This is the confusion matrix / heat map for random forest.
So in order to find correlations between different variables in our data, we used Python libraries that included Seaborn and Plotly that would help us visualize and analyze these relationships. And if you click on each image, you will get a visualization as shown here. So this graph shows the correlation between the airport of departure and the percentage of delays. So this one is really mushed together and it's a little hard to see, but you can see with labels on the bottom and also with the color code on the right. So the 3 airports of departure that had the highest percentage of delays were Chicago Midway, Dallas Love, and Metropolitan Oakland International. And this is all due to the fact that all three airports were in or near major cities. So Midway and Dallas are located in the cities in which they're named, and Oakland is located near San Francisco because Oakland, the city, is near San Francisco Bay Area. All 3 cities have populations of over 1 million. The 3 airports with the lowest percentages were Tri-State Walker Long, Flagstaff Pulliam, and Texarkana Regional Web. HTS is located in Huntington, West Virginia. FLG is located in Flagstaff, Arizona, and TXK is located in Texarkana, Arkansas. Okay, anyway, all 3 cities have populations below 75,000. This evidence suggests that the higher rates of flight delays in larger cities could be caused by the larger populations. Additionally, these cities tend to have higher traffic, which contributes to the higher demand for flights and also a higher rate of delays. The same reasoning can be applied to cities with smaller populations. The smaller population sizes means less demand and therefore less delays. So here we can see the correlation between percentage of delays and airlines flown. So WN, which is the tall blue one, stands for Southwest Airlines. And as you see on the very far right, the little green one, YV, stands for Mesa Airlines. So those flying with Mesa Airlines, they should know that their flight will probably go without a hitch. But if you are flying Southwest, just know that you have a high probability of delay.
Next, we have a map. So this map was created as an EDA for our data, and it was created using Plotly and a myriad of the statistics that we mentioned before. As you can see, the legend to the slide has delays in percentages from 0 to 70%. The majority of delays can be attributed to airports being in high traffic areas, like cities or busy hubs, as you can see on the West Coast and the East Coast. Guam and Puerto Rico also demonstrate these details in reverse. This is because they are islands and they usually have less traffic and airport management in their wake. The size values were based on square footage of the airport's runway. We did this in hopes that the size of an airport would show a correlation to the delay amount. The larger circles represent much larger airports, while the converse is true for the smaller airports. Smaller airports in more isolated areas, or those that see more traffic, have higher delay values than their more well-managed, larger counterparts. Meanwhile, larger airports in major cities also see amplified delay amounts that correlate to their high traffic. The surrounding population and temperature play a big role in addition to the size of the airport and runways. This leads into our next visualization. For this visualization, we took into account how weather may affect different flights. The same map from earlier is still used, and the airports are colored according to their respective temperature. The temperatures are represented on this map using a gradient from 0 to 110 degrees Fahrenheit. These temperatures were taken for every airport during their summer months and later averaged before being visualized. We picked the summer season because that is when flights are most common, and many choose to travel around the world during the summer. On the map, we can see that the airports closer to the equator tend to be hotter, and the southern airports can be extremely hot, whereas airports that are closer to the coast have more temperate and cooler temperatures. This is also seen as you move north and eventually towards Alaska. In particular, many airports aligning the West Coast and southern Midwest reached sweltering temperatures.
So this graph shows the percentage of delays in comparison to days of the week. So given that day 1 is Monday, we can see here that day 3, which is Wednesday, has the highest rate of delay, which is 47%, and that day 6, which is Saturday, has the lowest rate of delay. However, all days have similar rates of delay at between 40 to 50%. And lastly, here we can see the comparison between delays and flight duration. So from the scatter plot, it is evident that the data is skewed right. Flights with durations ranging from half an hour to 6 hours tend to be more delayed. However, a long-haul flight, such as a 9-hour flight, is less likely to be delayed. The highest rates of delay are about an hour to 2-hour lengths. And just so you know, yes, a higher amount on the left does mean skewed right.
All in all, our model ended up presenting us with 66% accuracy after using XGBoost and grid search. This did take us a while to compute as our data is pretty complex. And I'm sure some people are wondering why our accuracy is somewhat low compared to other models. And we ended up realizing that most of our data is not directly impacting the outcome of the delay, meaning that it makes it harder for the model to predict whether the delay will actually occur or not. While training, we found a relationship between the runway size and the number of delays, along with the size of the surrounding population. In the end, our model is mostly accurate, but may output a few false negatives and positives. Our journey to accuracy was one of trial and error, and we ended up gaining a lot of knowledge about correlations to delays in the end.
For our program to function with maximum accuracy, we used APIs in order to make our lives easier when it came to finding useful data. We used APIs to add more information relevant to our program, such as weather in real time to make our predictions on delays more precise. We have faced issues finding APIs and cleaning them when found, if we ever found them, and have had to drop an API altogether because the data was just too messy. And this is our lovely team. We wanted to introduce ourselves a little bit more, so.
Yeah, hello, I'm Emilia I. I'll be a sophomore at Corner Canyon High School in Utah. And yeah.
Hi, I'm Audrey Doratan. I'm going to be a sophomore at Denver High in California, and I'm a professional overthinker.
Hi, I'm Oviya Senthil. I'm going to be a junior at Folsom High School, and I'm a coconut water enthusiast.
I'm Emilia Auton, and I'm going to be a junior in California, and my computer is always crashing.
I'm Connor Hsieh. I'm going to be a sophomore at Beckman High, and I like slandering CoCalc.
Hi, I'm Nikkolos Miyoshi. I'm a rising sophomore at Diamond Bar High School, and I'd like to say on behalf of the team how much we are thankful for all that Brian has done for us, all that he's gone through, and all that he has to make this website a thing. And throughout 3 weeks, we just like to recognize him.
Brian, I'd just like to say I'm super impressed with my students, and it's been an incredible 3 weeks. And as a team, we'd like to remind you, catch flights, not feeling. Thank you for listening.